Welcome back, guys. We're going to try to do some more complicated Fnet equals MA problems. So if you remember in the last class, we talked about how we would decide which was accelerating, but we didn't have to break anything into components. That's not going to be the case anymore. We're going to have a couple additional steps. First one, a block of mass 2 kilograms is pushed along a frictionless surface. The force has a magnitude of 5 and is directed at 30 degrees with respect to the x-axis. Find the block's acceleration. So that's telling me that this angle in here is 30 degrees. So I'm going to draw the forces that are acting on this block. That would be mg F push and normal. My normal should be longer than my weight. Because when you have weight going down, but also you have part of the push going down. Like you're pushing a broom or a lawnmower and it has an angled handle, you're actually pushing down as well. All right, I don't like this one at an angle, so I'm going to get rid of the angle. And so what I'm going to do is I'm going to consider the two parts of F push Y and F push X. F push X is going to cause my acceleration. This is the adjacent side, so I'm going to use cosine. So cosine of 30 is going to be equal to F push X over F push. So F push X is going to be equal to F push cosine 30. Now, my acceleration is going to be in the x direction. So I'm going to let them know that I recognize this. So I'm going to say, in the x direction, Fnet equals MA. And I'm going to say that right minus left is equal to MA. So going to the right is F push X. So I'm going to call this F push cosine 30 equals MA. Why don't I call it F push X? Because F push X isn't real. F push is. So if I can express something that isn't real in terms of something that is real, that's better. And now I'm going to divide both sides by M. And so this is going to be 5 newtons cosine 30 divided by 2. And so this should give us an acceleration of 2.2 meters per second squared. All right, more complicated one with friction. A block of mass 2 kilograms is pulled horizontally along a rough surface. So it has a mu k, that's kinetic, it's moving, of 0.2. The force has a magnitude of 5. Find the block's acceleration. So I'm going to say that T is our pulling force. F fric is our force backwards. Mg is going down, normal is going up. And realistically, Mg and N should be 4 times as long as T. But usually when we're comparing things, we only really care how they relate to the ones in the same axes. So as long as your y-axis is appropriate length up and down, and your x's right and left, they really don't care about the other one. All right, so I'm going to say that in the x direction, I have an unbalanced force. So I'm going to write Fnet equals MA. And so I'm going to take force to the right minus force to the left, And that's going to be T minus F equals MA. But I don't know F. Mu is not F. Mu is the coefficient of friction. But I do know that for kinetic friction, the force of friction is equal to mu n. For static friction, it's equal to or less than mu n. But for kinetic friction, it's equal to mu n. So I can get n. How can I get n? I'm going to look at my y direction. And in my y direction, Fnet is equal to 0. So I'm going to take the forces up minus the forces down. So this is going to be n minus mg is equal to 0. So n is going to be equal to mg. And that's going to be 2 kilograms times 10 meters per second, or 20 newtons. Then I'm going to plug that in over here and get that my friction is 0.2 times 20, which is going to give me 4 newtons. And I can use that in my equation. If I divide both sides by m, I know that I'm pulling with a force of 5, and I have a force of friction of 4, and I'm accelerating a block that has a mass of 2. So 1 divided by 2 would be 0.5. All right, so a couple examples. How much tension must a cable withstand if it's used to accelerate a 1,200 kilogram car vertically upward? So we have a force of tension up. We have mg down. So this cable has to do 2 things. It has to lift the car, and then it also has to have an extra force in it to accelerate the car. So I'm going to look at Fnet equals MA. I'm going to take my ups minus my downs. And so I have T minus mg is equal to MA. And I'm going to get T by itself. So I'm going to add mg to the other side. And so we can see this now, that this tension is doing 2 things. It's lifting the car and it's accelerating the car. And I'm going to plug in our values. And I got 12,840. Another similar problem. The cable supporting a 2,125 kilogram elevator has a maximum strength of 21,750 newtons. What's the maximum upward acceleration it can give the elevator without braking? So again, same free body diagram, same equation, same equation of the situation. T minus mg equals ma. So A is going to be equal to T minus mg over m. So the maximum strength is the biggest tension. That's going to be 21,750. I'm subtracting the weight of this elevator, which is 2125 times 10, dividing by the mass of the elevator. This is from your book, and they use 9.8, so the answer is going to be, their answer would be a little bit higher, but I got about 0.24 meters per second per second.